Now, part 3 is about the binomial theorem. Here first we'll start with the integers. It's much more easier. Instead of drawing the Pascal's triangle to find the coefficients, we can easily go with the using combination. For example, this Pascal triangle, how it can be formed. The first one is actually what? A plus 1 to the power 1, and the second one is a plus b to the power 2. So easily, for example, if I say to the power 21, so instead of drawing the Pascal triangle, so how you can do it easily, the coefficients, just the four coefficients, it will start with the 21 combination plus, then you have the terms here, it will be a to the power 21, okay, let me write it for you, plus then the second coefficient will be 21 combination, a to the power 20, b to the power 1. As we know, the power of a decreases and it will increase. So for here, the coefficients are important. So it will be till how many terms we are going to have? We are going to have 22 terms, and the last one will be 21 combination. Okay, these two ones are 1 actually when you calculate. So in some formula booklets, you may not see them, or even in your book, they do not. You just put 1. But the idea is this one. For example, in your book, the formula is already given. As I said, they did not put in the first parts. It's a 1. And here's something new for you, maybe writing in short form by using sigma notation. We know sigma notation is addition, right? So you can easily write. So for any r, okay, I will just rewrite it again. It's a combination. When you open it, okay, when you open it, starting, you will get the same terms. And why I don't have to write it if you have the formula, but okay, if r is 0, what will be? And a to the power n, b to the power 0, it's a first term, so it will be a to the power n, actually plus, then if you put instead of r1, it will be n1, a to the power n minus 1, b to the power 1, and so on. So you actually get the same term. This one is a short version, it's good to know it. And also when you see it in some books, in some problems, don't be surprised, okay? And also in a binomial theorem, very important formula. Usually it's not memorized, but it's good to memorize if you want to find any term in your expansion. For example, they will ask you to find the 5th term. Without opening all the brackets, find the 10th term. So how you can do it, just easily say, if they ask you the 10th term, r plus 1 term, so you just go with the whatever n is with the 9. If you go with the 10 and 9, just subtract with 1, then it will be a to the power n minus 9, b to the power 9. Okay, so let me show in application. Here you have, okay, find the 9th term of this expansion. It's to the power 21. So I'm not going to open one by one. Instead, we can use these relations. So what does it say? If it's 9th term, r will be 8. So it will be 21, 8. 2x squared, our first term, to the power, it says n minus r, so it will be 21 minus 8 times the second term minus 1 by x to the power 8. So simplifying of this one you can find easily by your calculator. So this part will be 13 to the power 13 times x to the power 26. Okay, this one you can calculate. It will be positive times 1 to x to the power 8. So the simplified form, if you calculate also this one, will be combination of 21, 8 to the power 13, x to the power 18. So if they ask you the coefficient, you can easily solve it by using your calculator. Next question, question number 8 from your book. Also, you have some problems from you. Check it also. Find the coefficient. Okay, let's solve one of them. Let's solve the last one. Find the coefficient of x to the power 12 in the expansion of this one. Okay, I have denominator here. It's a tricky question. I have to be careful with this one. They're asking you the x to the power 12. So let's say I don't know this term. I don't know. So let it be, okay, nth term. So I will just use this formula, this property. I don't know which term is this, but I know the x must be to the power 12, so I will just write 12. I don't know which term, that's why I put r. 2x squared to the power 12 minus r, right, times minus 1 by x to the power r. Okay, so if I just open it, if I just simplify it, the first one is not important for me. I will just do this one to the power 12 minus r times x to the power 24 minus 2r. I'm just opening the brackets. Minus, okay, let it be minus 1r. I don't know r whether it's even or odd, x to the power r. Okay, so from here, if I just write simplify in simplified form, I just need these x's. It will be, if I, okay, let me rewrite it. I will just subtract 24 minus 3r. It will be, because r, we subtract the powers, minus 1 to the power r. So from here, I need for which r I can get x to the power 12. So I need to ask myself, which r will make it 12? So you just need to go 24 minus 3r equals to 12, and from here r must be 4. If r must be 4, then you can find the term. They're asking, okay, they're asking the coefficient. So it will be, from here easily you can see if it's r equals to 4, so it will be the coefficient 12, 4, combination 4 times minus 1 to the power r, okay, minus 1 to the power 4. This one will be 1, so it's combination of 12, 4. You can easily solve by your calculator. Forget about the to the power 12 minus r. We also have that term here. I almost forgot this one. So here, if r equals to 4, you will have times also to the power 8. Okay, let's also include this one. So this one will be your coefficient.